Hello everyone, this video explains dilutions. This is module 2, dot point 3.2. It's especially the second half of the dot point on dilutions, and it's not just about how to do the calculations, but there are lots of concepts, tips and tricks, terminology that are really helpful to know. So what is dilution to start with? We're familiar with that. It's when we add, for example, more water to something and it becomes less concentrated. So you can see in the picture here, this is potassium permanganate, very concentrated on the left. But if we added more of the solvent, it becomes less and less concentrated. Like if your cordial is too concentrated, you could add water to dilute it. Some terminology, you'll notice I didn't say your cordial is too strong. That is not the way we speak about it in chemistry, and this is important. So we talk about let's start with the more concentrated up here. It's got a higher concentration, it's more concentrated. We do not say stronger. And if it's less concentrated, more diluted, lower concentration, we do not call it weaker. Later on in chemistry, when you get to acids and bases, you'll learn about strong and weak acids, and that has a very different meaning. So do not speak about stronger and weaker. Talk about concentration, higher or lower concentration, more concentrated, less concentrated. How do we do the calculations involving dilutions? There's one key concept, and if you get that, it falls into place. When you dilute something, you add more solvent, often that's water, but you do not change the amount of the solute, the substance dissolved in there. For example, if I had 10 grams of salt in 100 mils of water, and then I add more water, I've still got 10 grams of salt in there. So it doesn't matter how much you dilute things, the number of moles of the substance stays the same. So I put here the key concept, the number of moles before dilution equals the number of moles of sample after dilution. And that allows you to do the calculations. So before the dilution, what's the concentration? Well, concentration is number of moles over volume. We've put a little 1 just to mean that's the first state that it was in, or the initial state. The concentration was moles over volume. We can rearrange it to find how many moles are in a particular substance. It's just concentration times volume. So before our dilution, there was a certain number of moles, and you could calculate it by multiplying concentration by volume. What about after the dilution? Exactly the same. There's a certain concentration, C2, and it's the number of moles divided by the volume. And you could rearrange that to find the number of moles. It's the concentration times the volume. So before the dilution, that's the formula to work out the number of moles. After the dilution, that would be the formula to work out the number of moles. But we have just said that the number of moles stays the same. The number of moles before the dilution is the same as the number of moles after, because we did not change the number of moles of substance in that solution. We didn't add any salt or whatever it is, or remove any. We only added solvent. So N1 equals N2. And so we can bring these two together, and we end up with C1V1 equals C2V2. In other words, the concentration of your solution before the dilution times the volume before the dilution is equal to the concentration after the dilution times the volume after the dilution. And that's the dilution formula, which is really helpful. They do not give this to you on the formula sheet, so you won't have it. So you need to decide, do you want to just memorize it because it's easy, C1V1 equals C2V2, and it sticks in your head? Or can you easily work it out because you know concentration is moles over volume, and you know that in a dilution the number of moles stays the same. But it is a pretty simple one, and a lot of students just memorize that. C1V1 is C2 equals C2V2. How do we use it? What do we typically come up with? Well, often they'll give you 3 of those unknowns, and you have to find the other. So they might tell you the initial concentration and volume, and they might say, we want to dilute it, we dilute it to a particular volume, find the new concentration. You could easily substitute and solve it. Or they may say, we want to prepare a particular concentration of solution, so they give you C2. What volume do we need to dilute it to? So you need to find V2. So often they'll give you C1 and V1, initial concentration and volume, and you need to find one of these. But there are some tricks. A big one, the final volume, C2, is not the same as the volume we add. This is a big trick. If you're aware of it at the start, you won't make the mistakes. Here's 2 examples. If we take 100 mils of solution and we dilute it by adding 200 mils, what is the final volume? Sorry, that's meant to be V2. The final volume is 300 mils. the initial 100 plus the 200 we added. So the final volume is more than the volume you add. A different example, 100 mils of solution is diluted, and you calculate the final volume, so that should be V2. Final volume is 500 mils. And you might be asked to calculate how much solvent do we need to add to get this final concentration, and you work it all out and get 500, and you put that as your answer. But that's not the answer. How much do you need to add? Well, you need to take off the solution that's already there. The amount you add is the 500, the final volume, minus what you started with, 400 mils. So that's a trick just to be aware of. And if you're understanding the question, you won't make that trick, but just be aware. Another thing, dilutions are based on ratios, and you might be able to work that out if you're mathematically minded. That actually means any units will work. If you're in mils, it works. If you're in liters, it works. If you're in gallons, whatever other units there are, it will work. But all the other calculations you do require you to work in liters. So I generally say convert everything to liters, and that way it becomes a habit and you don't make mistakes on the other questions. If you start to think, oh, it's a dilution, I can use mils, and you get the right answer, you might start using mils in other questions. So I would say if you're not confident, convert everything to liters as a general principle. But if you really do understand ratios well and you think you can handle that in this one situation, it's okay not to convert units as long as they're the same on both sides, then you can do that. And one last thing, dilutions, you often won't come across them just by themselves as a question. Often they're part of a larger multi-step problem. So we might do a preparation and we mix something and then we dilute it and then we separate it and then we measure something, and the dilution is just one small step that you need to do as part of a larger problem. Now, one last thing before we finish. Volumetric glassware is going to be used for dilutions, so we don't just dilute to any sort of concentration ratio volume, we use the volumetric glassware. So a dilution will typically start with the volume that matches one of your pipettes, because that's what you use to transfer your solution into the flask, and the final volume is normally going to be the volume of a volumetric flask. So for example, you might dilute 50 mils to 100 mils, or 25 mils to 100 mils, right? Because you've got this equipment that you're going to use. And that means you normally have set ratios. If I take my 10 mil pipette and I put 10 mils of solution into the 100 mil flask and then fill it to the mark, my final volume is 10 times the initial volume. So my final concentration is 1/10. And so I can dilute to 1/10 using that combination. If I use my 5 mil pipette, my final volume is 20 times higher, and so my final concentration will be 1/20th. And you'll find this works in ratios and proportions, and you'll get used to the equipment that we use and typical sort of dilutions. Okay, hopefully that helps you to be able to do the questions, and the activity on Classroom matches all of this almost exactly.